Hello everyone. So in this one, there won't be as much coding. It's more so a conceptual idea, and it's going to be useful to implement this for your homework as well, which is just going to have a little bit of a variety based on these shape classes. So again, with our polymorphism, this is an idea that whenever we're doing things with our objects, we can kind of change our behavior based on the type of object that we're given. So again, what we've seen so far is we coded maybe a sorting algorithm for a certain type of object, but if you try to make it for ints and then you put it in a string, it won't work. If we take a look at our search.java file, though, we actually already did a bit of polymorphism here. If we notice here that the names of our methods are a little bit different, but these methods will actually work based on, regardless of the object that you provide for it, especially this one here. So what this means here is that this method is going to run, and it's going to run this code regardless of whichever type of object we're given. And the reason that works is because the T over here is provided for us. So what we would like to do here is kind of expand on this idea of polymorphism by taking a look at a few of these shape classes. So again, this variable type of behavior based on the object's input that we're getting is what is called polymorphism. And then if we see here, our inheritance is going to give us another way to achieve this polymorphic behavior. One more thing here is we can take a look at our basic shape classes, such as the polygon. And let's go ahead and open this polygon.java file up here in our week 7. And so in week 7, we have the poly driver in the one file. And then if we take a look at the shapes class over here, there's a polygon.java file. Now you'll see here that we have this name up here that's called a public abstract class. And because what we're trying to do here with this interface is implemented for all these objects. But for this polygon class, we could see that we have a dimension of 1, a dimension of 2, and then we have a number of sides as well. We also see that the polygon takes in some of these values as well using the constructor. So if we provided these, it's going to set them based on the areas here. Otherwise, it might just default it to here. And then we can have this longest side function that returns which side is the longest for us. We have a toString, and then we have a basic return 0.0 for our area. Now, if we take a look a bit of the notes a bit as well, we'll see that we have a subclass called square that takes in a parameterized constructor, one that has parameters that we put in, a toString method, and then an area method. We also have this triangle class that also has a parameterized constructor, a toString, and an area method. Now, if we actually take a look at these pieces of code here, we'll see that each of these ones of our square is going to extend a polygon class. And what that means is that it's going to go ahead and take in these variables for it. And you'll see here as well that when we say super, we provide the two sides of the square, length and the width of the square for the, the same side because the square is going to be equal, and the four sides to this constructor here, which is the polygon constructor. You can kind of consider this polygon like this instead of it saying super, but we have to use super for Java. And you'll notice that it's kind of the same for the triangle. We take in a few more parameters because the triangle is a bit different, but you'll see here that the public toString and area are both overloaded. And you'll see if you hover over this green guy, it says override shapes.polygon.area. So now we can see here, and we'll take a look at the little notes here in a moment. If we take a look at this poly driver, we'll see we'll make an array of polygons, and then we create at our first polygon object a triangle. At the second object that we're making is a square, and the third one is a polygon object by itself. And we loop through this and we output each of them, and we can see here that we get a triangle right here. It's going to have a height of 2 and a width of 4, and it has an area of 4.0, and the longest side is 4. Great. And essentially here, what if we go ahead and take this look at this polymorphism? What we're trying to ask here is, what if we assign a derived class object to a base class reference, then call a method? Which class does the method come from? What that is essentially trying to say here is that we have an array of polygons. So this should hold an array of polygon methods, and we're polygon objects, and we're trying to say, well, does it get called from the derived class, i.e. a class that is inheriting from Polygon, or does it get called from Polygon itself? And if we take a look here, there's going to be three scenarios that you encounter. If the method is only defined in the derived class, there will be an error unless we cast a reference to the derived class. So let's go ahead and try to make a method here in triangle. Public void unique method, and all this will do is it's going to print out hello world for us. And what I want to do here is I want to try, and inside of this objects of Polygon, what I want to try to print out is the let's see here, p array 0. And we'll see here that my p array 0, because this is a triangle, and we remember it's a triangle from the line of code that's right here, we'll see that I actually can't access this unique method that I created, because we have a reference for all of these, or excuse me, we're assuming that it's going to be a polygon. So this is where some of these issues arise, where even though I have this unique method here, we'll see that it's not going to be printable, or it's not going to be accessed because we don't have a reference to it elsewhere. So that is what we mean when we say that it won't have a unique method work for us. The other scenario, though, is that if the method is only defined in the base class and it's not a private method, then that version will be used. So if I have a unique method in here, and let me go ahead and try to grab this back out here one more time. I'll delete it from my triangle class, and then I'll put it right here. What I could try to do now is I could try to do my print line of parray 0 dot unique method, and now we'll see that my unique method is popping up. And so essentially, because it's inside of this Polygon class, it is, all the other classes will have access to it. And now we have the last one. If the method is defined in both classes, then the derived class version will be used. So right now, if I go ahead and I say p array of 0 dot unique method, let me say hello world 1, so that we're in the Polygon method, and I print this out, we'll see I get hello world 1 each time, and we're inheriting that from the Polygon method here. But what happens if I override this method in triangle, and I save it as 2, and I try running my code one more time? We'll now see that I'm calling the method from my derived class. So again, what happens and what becomes an issue is that if I delete this from here, I actually won't have access to it, because this is an array of polygons, and it assumes that the object is a polygon here. But if I have it created in my Polygon class, my code will reference, hey, okay, the triangle wants to call this method, but the triangle also has its own version, so we're going to use the overridden version. Things like these can be a little tricky, and there's a lot to unpack with them, so please fiddle around a bit with your code, add in some methods, and see what happens and what doesn't work. But this is a really important example of polymorphism. And again, the general idea that a method called by reference will be based on the type of the object that the reference points to, not to the type of reference itself. So again, even though the type of object is a triangle, we're pointing to a polygon, so we need to make sure that we take that into account.